Good morning all of you. My name is Jayashree. I am from BCA batch 2 4th semester. Today I am here to present the topic that is linked list, how we create a linked list, how we traverse the linked list, and what is the use of linked list and what is linked list also. And first of all, I would like to thank Soni sir for giving me such a wonderful opportunity to present this topic. Before moving to this topic, what is linked list, what is the use of linked list, how we create a linked list, I would like to explain you what is self-referential structure. So you all know that what is reference means it stores the address. So the self-referential structure is the structure that holds the address of similar type of structure. First we create the structure, then this one is self-referential structure, means it stores the address of next node. So here I create the structure. When we create the structure, it means we create the node, because a structure is a type which stores different data types. So we use the structure. Here it is node. So it contains the first node. The node has two sections mainly. First section is data and the second one is next. Means it contains the address of next node. So how we access this data? We have to access this data by giving the head arrow data, and we have to access this address by giving head arrow next. So basically this is the node, and we use the self-referential structure in linked list to access the next node. That's why we use the self-referential structure. So what is linked list? So linked list is, as the name suggests, it is a list. Means it contains the elements in it, and the linked list is consist of node. Means each containing node has a data and a pointer which contain the address of next node. And we create the linked list by allocating the memory at runtime. By using the malloc function, we allocate the memory at the runtime, and it allows the more flexibility in size, because if you use array, the size is fixed. We declare the size, but in linked list the size is not fixed. It is resizable. So we have to. This is the flexibility in size. In a structure also, we have the cost of insertion and deletion in linked list is also easy as compared to array. And we do different operations on linked list, that is insertion, deletion, that's it. So basically there are two types of operation, that is creation and traverse. How we create a linked list, how we traverse, means how we display that we create the linked list. So this is linked list, means I already told you that when we create linked list, we have to create the node. So first of all, we create the node of different. This is the node that consists of two sections, data and the next. Next, it is stored the address of next node. So by linking this address, we create the linked list. Here this head pointer point this node, first node. By accessing this node, we have to access this node also, because this is the data. If it is any character, float, integer, any data. And here it is the next, that it stored the address of next node. And it is also data, it is stored the address of next node. And at last, it does not store the address of any node, so it is null. Here it is null. So this is how the internally memory allocate in our system. That we assume that it is same as when we create node, it is like that in memory, it allocates the memory. So what is the advantage and disadvantage of linked list? Advantage is that it is dynamic size, means it is dynamic in nature, that it is not static. We have to create the size more and more as we want. And efficient insertion and deletion also, because if we insert any node, it is very efficient, and deletion is also efficient. And what is the disadvantage of linked list? That extra memory will be consumed. If you create the pointer, it will consume extra memory. And the sequential access means we have to access the values in sequence manner. And the lack of random access. In array, we have to access the element by giving the index number, but in linked list, we have to access in sequential manner. So what is the difference between array and linked list? Linked list, the comparison of array and linked list. We all know that array is also used to create the list and linked list is also used to create the list. But what is the difference behind it? That array is the static in size, means the size of array is fixed and it is constant time access, means we have to access in constant time. And if you create any array, it is a contiguous memory, means this is not the random memory, it is contiguous and it is static in nature. And what is linked list? Linked list is dynamic in nature, means when we create the linked list, we allocate the memory by using malloc function. So the creation of memory at runtime, that's why it is dynamic in nature. It is linear time access. This is non-contiguous memory, means the memory is not contiguous, the memory is different. We have to create the linked list in a random way and we connect the one node to the next node by giving the address of the next node. So how we create the linked list? What is the logic behind it that we have to create the linked list? So first of all, when we create a linked list, I already told you that we have to create a structure, and after that we have to allocate memory by using the malloc function. Then we have to set the data value, or after that we have to update the pointer to the next node. In the next, we have to give the address of next node. That's why this is the logic that we use to create the linked list. So here, creation of linked list means how we create the linked list here. Here I have declared the structure, that is type def struct node. The structure name is node and it consists of one data, that is int, and this is the self-referential structure which name as next, and this is the structure that I create. When we create the structure, we create the node. So this is the node I have created that consists of data, and the next it contains the address of next node. So by creating a structure is not sufficient. We have to create we have to allocate the memory at runtime. So we use the malloc function. Here the malloc function is created by giving the size of this structure, and this malloc function returns the address of this node, and this address of this node is contained to the type structure. So here this is the first node and it contains the data, that is int I declare, and this is the next, means it contains the address of this node, and this contains the address of this node, and this next contains the address of this node. By giving I will explain you by going with. So here this is the node, okay, and this one is also one node and this one node. So what is the logic? I am going to tell you that this is consists of two sections. One is data for data, and next one is next, means it contains the address of next one. Here also data next, here also data next. So I am going to take three pointers, that is H, Q and R. So here H point the first node, that is H, and Q is also here, and R is used to create the next node. So R we use to create this node. So then this is the R. So in first the value of this is null. Next is null because it is not connected to this node. That's why the value of next is null. So what if you want to connect this node to this node? What will we do? We just create. If you create this H next, then link is broken. The link is break. So that's why we use different another pointer to update the value of next. So I use next Q pointer that contains null. So after that we create the next node. Then the Q equal to Q next equal to R. Means Q next, this one to this node. After that, after pointing this node, this establishes the connection. It establishes the connection of this node. So we create this, and we have to update Q to R. Means Q is firstly the Q is here. After that, when we update Q, the Q is here. So in this way, we create different. We create the node as much as we want. So here the Q is R. Then we create the next node. Then the R point this. So Q next become R equal to R, means this is representing this node. So this is become R. After it here, the Q come here. Here there is no any node. So Q next is equal to null. Means like we create the three nodes. After that, if you not connect any node here, we just leave it null. So this is how we create the linked list. I am going to create the linked list as much as the user want. If the user say yes, the linked list is created, and if the user say no, the linked list is not created. Then what is when linked list is created? Then how we display the linked list?
1.
I have told you how we create the linked list. So here I am going to explain you how we traverse the linked list. Means if you create the linked list, how do you see that the linked list is created or not? So here the linked list is already created. I already told you that I explained you. So here this is the linked list. How we traverse the linked list? Here the H point to this node. Okay. So if H point to this node, then it contains some value. Then H next contains some value, means it contains the value of this node. Okay. So here if this next is here, then we have to create like y. We use the y function. Means if this node is here, if H is here, it also contains the value next. It is not null because it is also on node here. It is connected next. But what if the H is come here? If H is here, okay. So if H is here, then it will print the data. After that, it will go to this. Means H equal to null. So the while loop is continuously run until the H become null. When H become null, the while loop is terminated, and by displaying all your data of this node. Okay. So I am going to write a program how to create a linked list, how we traverse the linked list. I create the linked list, how we create the linked list. So first I include the stu.h and then std.leave.h. This is the library that we contain to take the input and output, and this is the library that I use to create the malloc function. So before this, I create the structure, that is node. First of all, I create a structure, that is type def struct. Then I give the name of this structure node. So this structure consists of one data, that is int. You could take any data, that is float, character or anything. And I am using the one self-referential structure that I already explained to you. That is struct node. Then I named it as next. So and here this is a type that's why I am using node here, because by using the node we call the structure. So here I created one structure that consists of one data and one is next. It contains the address of next node. After that I am using the main function, int main. So it contains node pointer. Means I take one pointer which is of type struct, node. So it is a pointer. So how we create the linked list? I am going to use one function. I am going to create one function that is creation of linked list and one function for traverse the linked list. I am using to create the function to creation of linked list. That is, it will return node. This function will return the head. That's why I am taking head. Then creation. The function name is creation. That will not take any argument. That's why I am creating the 3 node here. First node is asterisk H. Second one is asterisk Q. Third one is asterisk R. I have created 3 nodes. Means first one is head. Second one is used for, first one is point to head. Second one used to update the next value, and R is used to allocate, R is used to create the next node. So I am going to create one node, that is head, H equal to node, size of this node. I am using the malloc function to allocate the memory dynamically. It returned the address of this allocated memory to H. I am going to take the input from the user. That's why I am printer. First of all, enter data. I use scanf for taking input from the user. Scanf. Scan %d, that is invisible, and take the input H data. So here I used to scanf, means I used to take the input from the user, that for which I allocate the memory. This is node, means I take the data value. So what is in next? In next there is no any node, so it is the null. H next equal to null. Then I take one pointer also, that is Q, which is used to update the next value. So in first node the Q is on head, at head. So Q equal to head here, H. So I am going to tell if print f enters more data. If user want to make enter more data, it is yes, and if not, it is no. Here I have to use one character to take yes or no. Cat ch. Ch equal to get che. So if user say yes, the node is created. If user say no, the program is terminated by traverse your node. So if while c equal to y, means if user want to create more linked list, then it is y. I am going to copy and paste all this. So here I created node. Here I am taking R to create next node, and here R data. I am taking the data of R, and here what is the value of R next? It is null, and here so here also R is next null. Here H next is also null. So it is the first node and it is the second node, and the Q is on the first node. So if you want to link this node to this node by using the linked list, we have to put the address H. So here means Q. Here Q. So here Q equal Q. Q next equal to R. Means the Q is first of all Q is here at H, means at the head. Then if you want to store the address of this node R, then we have to put the Q next equal to R, means Q next point to the R node. After that we update the Q to the next node. So here Q equal to R. I update the node to the next node. So if the user want more data, then it will say yes, then the while loop is running. If the user want to terminate this program, then the user have to write end to terminate from this program. So this is how we create the linked list. I am creating the linked list by taking 3 pointer, and this is how we create the linked list. I am going to run this program. It will not give any input. Let me check that it will give the error or not. Yeah. CH. So it will compile successfully. So I am going to, it means that our linked list is created. I am going to show how the linked list will traverse the linked list, means how we display the linked list in the terminal. So I am using the another function that will not return any value, that is void traverse. First of all I am call this create. This create return the pointer H. Creation. So it will return H, means head pointer it will return. I am going to create a function that will display the linked list. I am naming the function as traverse. After that, while H not equal to null, then print H data. After that, we have to allocate this head to the next node. Next. Here we have to return H. Because this is return the pointer, that's why we have to write return H. Return H. No, here we want to return H. So this is how we create the function to traverse this linked list. While H not equal to null, means if until H is a point at last node, it will print our data. Then after that, next is update to the next node. I am going to run this program to show the output. Here we have to take argument as node H, and we have to call this traverse function. By giving H head here. This is the output. Enter data. I am going to enter 2. Then if I want to enter more data, then we have to type yes, y, then enter data 5. I want more, then yes, enter data 8, one more, yes, enter data 9. So this is how I create this node, and I am going to terminate this program by giving end. So and this linked list, it traverses here, means I created the linked list of 1, 5, 8, 9. And if you want to create more node, then we have to put yes here. If you want to terminate this program, we have to put no, and the program is terminated by displaying your value of the linked list. So that's all. This is how we create the linked list, how we traverse the linked list. Thank you.